Hello, and welcome to this Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenter and go over today's agenda. So with us today we have Jodeep Sanyal. Jodeep is the Product Line Manager of General Industrial at Smiths Interconnect. So today Jodeep will be talking about the following items. First, we will examine the challenges with HVAC system design and the role of cable and connectors. We will share Smiths Interconnect's experience in helping HVAC system designers, and we will also learn how to select the optimal connector for each HVAC application, and then we will have a Q&A session or kind of open discussion at the end. So before we get started with our agenda today, I would like to ask our audience a polling question. So if everybody could take a moment to submit an answer, we would greatly appreciate that. So the question today: while designing an HVAC system, how important is the choice of a reliable connector to the overall architecture of the design? So we have three options here. Extremely important, hence considered at early stages of the design. Somewhat important, and hence considered at mid stages of the design. Or non-important, and hence considered at later stages of the design. So if everybody could go ahead and choose and submit their answer, we would appreciate that. I will read the question one more time just to give everybody a chance to submit. The question is, while designing an HVAC system, how important is the choice of a reliable connector to the overall architecture of the design? So as I mentioned, three options there. Submit your answer, and then we will go over the results. So I'll give everybody another minute or so to submit. All right, guys, I'll read the answers one more time, and then we'll go over the results. Extremely important, hence considered at early stages of the design. Somewhat important, and hence considered at mid stages of the design. Or not important, and hence considered at later stages of the design. So again, I'll give you guys about 10 more seconds to submit your answers, and your feedback is always important to us, so thank you for participating in the poll. All right, and with that, I'm going to pass it over to Jodeep to kind of talk about the results of our polling question today. So Jodeep, go right ahead.
Thank you, Katie. Good morning, good afternoon, good evening from whichever part of the world you're joining. The polling results looks so representative of the discussions we typically have with our customers, because connectors in our experience play quite a pivotal role in the overall architecture of a design, on the electrical system particularly. So I suppose that this polling result does reflect that part of the discussion we have with our customers. So with that, let's move on to the rest of the discussions about the webinar. But before I start, perhaps particularly for those who may not know Smiths Interconnect that well, this is just an introduction slide. Smiths Interconnect is a leading provider of technically differentiated electronic components. Now, what do we mean by technically differentiated? Over the next many slides, I will hopefully delve quite a lot about how do we design products to make a difference to our users' applications. We have got subsystems, microwave, optical, and radio frequency products that ultimately connect and protect and control critical applications in whether it is commercial aviation, defense, space, medical, rail, semiconductor, test, and industrial market segments. We have over 60 years of experience, and on the global map that you see, we have over 15 sales offices around the world, 15 manufacturing sites manufacturing the products that we offer in our portfolio, and 17 R&D centers. So before we go on to talk about connectors, this is quite an interesting kind of a percentage or a number to start with. A study that was commissioned by Emerson showed that 15% of data centers outages are due to cooling system failure. Now, I'm not here to argue that 15% or 20% or whatever the final number is, from their perspective, they're all down to a particular equipment, if you like, whether it is a connector, whether it's cable, or whether it's any other system that's connecting to a cooling system. What I'm here to kind of advocate and argue, if you like, that connectors, whether we like it or not, do play a role in that failure mode. And we, as connector designers and manufacturers, do have to recognize that. So when we talk about connectors, one of the things that we genuinely promote and advocate is the total cost of ownership. Now, the concept of total cost of ownership is nothing new, right? It is kind of made out of initial purchase cost that you pay upfront or first time when you purchase that piece of kit, a cost of installation, cost of operating. Now, what often gets missed out of the calculation, because generally speaking, when I deal with and speak with a lot of procurement managers, in their own admission, they say, right, it is sometimes quite difficult to put a number against it, is what is the cost of not operating the equipment? And this is where I suppose the crux of the discussion is that you design a system, you design everything, you've taken all possible cost in a spreadsheet, but sometimes it's genuinely difficult to attribute cost of not operating it. And our experience suggests that that last piece is quite a big number for the end use application, because often critical infrastructure run at the back of HVAC systems. Now, with this kind of a general statement made, let me just move on to some of the more specific aspects of it. Now, HVAC system, most of you are completely conversant of what a HVAC system is, and therefore I'm not here to kind of explain the ins and outs of what makes up a HVAC system. What I'm here to kind of just bring out here are some of what are the application challenges that we have seen in HVAC systems. First is space, right? Any and pretty much every HVAC applications that I have been to, every time I remain surprised actually that how much of engineering excellence goes in packing so many different equipment in such a small space. So for a system like this, space is critical. It's a real estate, right? And typically from a connector standpoint, what in our discussion that comes out is smaller the better. And typically speaking, Smith Interconnect's hyperboloid contact design, and this is something you will hear me talking a lot across the product, across the rest of the slides. The contact, the heart of the product, the way we design it is typically has got a higher power carrying capacity, which basically means that for a like-for-like power specification, electrical specification, Smith Interconnect's products are often one of the smallest in the market. The second piece that often comes here is temperature and moisture. Now, in case of electrical systems, that includes cable and connectors in HVAC system, often is installed behind cabinets or behind kind of panels that are not very well circulated. Temperature and humidity over time, humidity you reach the dew point, it starts condensation. It deteriorates the material properties over time. We will delve into a little bit of a detail of a product that we have got a huge amount of pedigree on developing an IP67 connector for an application of this nature. And this ingress protection is quite vitally important, and I will speak about that in the next few slides. Technician friendly. Now, what goes hand in hand with space is that how amazing of a job that a technician has to do to make sure that their piece of work of connecting a interconnect solution is done to the highest degree of quality and reliability. Now, the designs that we have got actually lends itself keeping the technician in the heart of that product design, because often they have to almost like, acrobatically bend and kind of connect things, sometimes putting their head in, just about looking through a small hole or a small area to make sure that their piece of work is done to the highest professional standards. And finally, wiring problems, vibration, you name it, right? Corrosion, fraying, or disconnection could occur to the wires and disrupt the flow of power, right? So again, I will talk a lot about how we ensure that these failure mechanisms are captured and the product is designed keeping those in mind. Right. Now, I'm not going to necessarily go line by line on this slide, but I really want you to reflect that when we talk about, go back to the first slide of 15% failure mode. One of the, the few of the things that ultimately contribute where connectors become part of the problem statement are related to one of these four boxes. Either it's due to temperature, or it can be due to vibration load, because remember that often connectors and electrical systems are resident next to very high vibrating or equipment. Humidity is a big piece in this discussion, and goes with it is contamination, because often HVAC systems are kind of put in place where the natural environment is dusty. So it goes without saying the contamination has got a piece in this failure mode analysis. Now, as you would see in each of these boxes, we at Smiths Interconnect, we have considered quite carefully how do we ensure that the product that we are designing is actually being designed keeping these environments in mind, right? And over the next few slides, hopefully I'm going to bring to life some of these failure modes and connect the product back to these, and how we try to make sure that the HVAC systems are reliable, or at least a connector, if you like, doesn't become one of the areas of problem statement. The other piece that often comes out when we generally talk to our customers about HVAC systems, and this is a very broad summary, if you like, of many discussions that we have in many different end-use applications. So the first thing, I suppose, that resonates in multiple discussion is the word reliability. And if there's any one particular word that perhaps is common across so many different discussions, I would definitely stress on the word reliability. So reliability is perhaps one of the foremost consideration given by our customers. Ease to assemble, small footprint of connectors for, in some cases, high shock vibration applications, and harsh environmental condition. And when I say harsh, I don't mean, the word harsh can mean many things to many people. Harsh can sometimes mean a marine application. We are definitely not talking about that. We are talking about harsh in relative to HVAC system application. Now, within that, again, if you ask, and when we talk to our customers to broadly explain before we really get in the nitty-gritty of the their pain points, their technical specification. If you really talk at a high level, try to request them to explain what they're after, some of these things come out, right? Rugged connector, reliability, as I said, for critical application. For example, if you're running, I don't know, for example, a data center, the last thing you want your HVAC system giving up. EMI, RFI performance, right? Because often so many different equipment being kind of packed into such a small environment, it can sometimes become a perfect environment supporting kind of EMI performance issues. And finally, compliance to various standards. And this is very, very critical, particularly when you think about quite arduous application requirements or requirements like fire and smoke requirements. So this is just a slide, if you like, to, how do I call it, guys, summarize or encompass perhaps tens of different discussions we have had with so many different customers around HVAC system, and we try to somehow ask them to crystallize their thoughts in words. And this is what perhaps comes out in many of those discussions. Now, this, given the application that we are talking about, we could have picked up a lot of different products from our portfolio. But over the next few slides, I'm really going to labor on a couple of different products, M12 and REP. And the list that you see here on the right is just a simple articulation, if you like, of where some of these products can go. And remember that when we talk about this as, you pick up anything like a pressure vessel, for example, we are really talking about the electrical system that surrounds these equipment. For example, you've got instrumentation, you have got other ancillary equipment supporting these core equipment, if you like. And we're really talking about how these products can support the overall equipment structures, if you like, and the overall architecture, coming back to the electrical distribution cabinet. So before I delve deep into any one of those two products, I just want to perhaps take a minute or two to explain. You remember I talked to the very first few slides, or the first slide, about introduction of Smiths Interconnect, and we talked about technically differentiated products. Because when we design products, what is absolutely crucial in our initial discussion phase, in our understanding of the customer's pain point, are related to obviously the end-use application requirements, which sometimes are very hard, technical specification you can easily measure. But we also talk about what in the surrounding of the product, where this is going. Or as I said in one of my previous slides, about who is going to do the job, in what sort of environment they have to do the job, the technicians, right? It's quite important for us to understand them, because we are basically trying to design something keeping all those aspects in mind. And in that thought process, one of the critical aspects for us to think about is the contact design. Now, the contact design is almost, you can say, as the heart of the product of a connector design, because often many of the failure modes can attribute back to the contact design. So with this, I'm kind of presenting to those to whom you may not be aware of it, from Smiths Interconnect. We champion one of the product technology called hyperboloid contact technology. As you would see on the bottom right, the word hyperboloid is because of the shape of the contact, and you see the shape of the contact has got a hyperboloid kind of geometry. Now, this particular product, or this contact technology, has got again, a very tried and tested in critical applications. But the key essence of this particular technology starts with a low contact resistance. And you would ask, why is this important? Before I really get in the connector side of the story about contact resistance, it might sometimes worth kind of standing back and reflecting a parallel life. Just before joining this webinar, I made a cup of tea for myself. I've got a kettle at my home, and think about the case, right? Every few months, I typically descale the kettle. Why? Because firstly, kettle do take up a lot of power, and if it builds up a lot of scaling inside it, then it just takes longer for that water to boil, and the kettle becomes inefficient over time, right? In the same way, connectors over time develop and increase contact resistance. Now, from an overall electrical performance standpoint, you need to ensure that you've got very low contact resistance, because if your contact resistance is high, you basically, like my example of a parallel world of a kettle, you basically develop greater amount of heat generation will happen around the contact. And worst come worst, that heat will start affecting the insulator, and therefore, from a total failure mode perspective, it can completely bring stop a system. So as simple as, what you would think as a contact can affect and bring down or stop a complete system from operating firstly ineffectively or inefficiently to a complete stop. The second thing that this contact technology does to great about is a 360-degree wiping action, and that you see on the picture, that unlike any other contact technology that you typically see in the market, where you've got various pins, various points around the male pin, over here the male pin gets completely surrounded by the contact. The third thing is about the higher current carrying capacity. Now, you remember I was talking about smaller the better in case of a connector in an environment like this. Now, that is attributed to a contact technology that we have designed, because given the design, typically speaking, our design is able to carry 30% more current carrying capacity in comparison to similar power ratings from other connectors, which ultimately leads to what? To overall space and weight savings, which again are crucial kind of requirements in an industry like this. The second point is about shock and vibration proof. Now, as I said, in a typical HVAC system, you have to live within an environment that you are close to vibrating equipment or rotating equipment. So it operates in extremely demanding environments. It's almost like virtually immune to high mechanical and shock and vibration. Now, why is this important? Now, you might think that, hang on, and it is not as vibrating of an environment as perhaps I'm trying to make out of it. But from a connector standpoint, that little vibration that you, or small vibration, amount of vibration that you see in an overall system, that results from a mechanical standpoint, fretting corrosion. And why is fretting corrosion such a problem with the contact? Because fretting corrosion not only degrades the performance of the connector from a life cycle standpoint, but again, if I take a complete circular view of it, fretting corrosion ultimately increases contact resistance. And I'm not going to labor the point again about why contact resistance is so very important, but you get my point, right? So with higher fretting corrosion, your contact resistance increases, and the failure mode kind of progresses from that point onwards. So hence it is quite important to select contact technology that is almost virtually immune to shock and vibration, therefore will not lead into fretting corrosion and the rest of the failure mechanisms at the back of that. Low meeting force. Now, although these connectors are quite small, but if you keep the technicians in mind when they have to do this job so many times, multiple times for getting a system up and running, these little things make a huge difference to their day-to-day job. And therefore, the overall piece is keeping the technician in the heart of the discussion. And finally, long contact life. A contact of this nature is typically speaking gives an industry-leading meeting cycles of 20,000. So if you package all of this together, the heart of the product, you have basically secured an extremely high-quality contact at the heart of the product, around which the rest of the product develops. So with that, let me get into one of those two products I said at the beginning, REP, and the second one is M12. Now, the REP is a rectangular-shaped, easy disconnect product. It has got keying devices embedded into the connector. You will see on the bottom right a couple of pictures of different configurations. So the standard insulator comes in a body of either 2, 6, or 12 contact positions. And the picture that you see on the bottom left is a representation of the 12 contact position. The REP comes in 2 different variations. A polycarbonate thermoplastic gray color that you see on the bottom left. This ensures flexibility in particularly cable-to-cable application with prim contacts, right? Equipped with locking clips, and I'm going to talk about them. Perhaps the picture tells more about the locking clip that I'm also going to talk about in a few minutes. And the one that you see on the bottom right is made out of polyamide material, black in color, as it shows in the picture. Is temperature resistant to soldering processes for PCB applications with straight or right angle PCB termination contacts. Now, this can be delivered if this is what your application requires or your system requires in a pre-cabled assembled conditions, complete and fully tested to your specification. Now, this particular product comes with 2 different types of contact technology. The hyperboloid contact technology, which I talked about in my previous slide, and there is another reliable contact technology called the MR contact technology. It comes with IP66 and 67 sealing index with a rear grommet, and I will in the next slide labor a little bit more about why is it so important in an HVAC application for this sort of ingress protection. Its resistance to category 2, high current carrying capacity of up to 18 amperage, qualified to various different international standards. Now, the first standard that you see on the second last bullet point is particularly for the rail market, which where we have got a huge amount of success stories on using this product. And if you like, the rail is a perfect environment of many of these failure mechanisms coming to life. So this connector has almost become a de facto standard in the rail market for HVAC applications. And again, fire and smoke toxicity compliance, again, some of the things are vitally important to be kind of present in this market application. Now, as I said quite a few times, that the technician is quite important in this piece of the equation, right? It's just not a hard technical requirements of, so many amperage voltages, et cetera. When you keep the technician in the mind, the thing that we have designed is the audible locking clip to facilitate blind mating. Because as I said in one of my previous slides, think of the technician, right? They might be doing all sort of acrobatic kind of postures to get some of these things up and running, right? And in case of hyperboloid, you can pretty much use or you can use one size contact for 0.5 to 2.5 square millimeter of cross section of wires. And if you use the MR contact, then there are 2 different types of contacts depending upon your cross section of the cable. The beauty of the product is with this product, you don't need any special tool requirements. So that basically means, from your spend standpoint, it reduces your supply chain spend, maintenance, and that sort of area. It's got 4 coding or keying devices included in the design, and has got multiple different configurations because you name it, cable to cable, clips, front and back panel mounting, all those different aspects of it. PCB I talked about, all those things have been taken care of in this design. So when you look into the product in a little bit in more detail, individually, if you like, I start with the top left. With the contact, it's one size fits all, but particularly when you're using a hyperboloid. If you're using MR contact, then there are two different contacts for the cables. So this limits the number of spare parts or parts that you have to stock on the shelf. It optimizes therefore your logistics and your cabling operation. From an electrical spec standpoint, it can do voltage rating of 230 volts for PD3. Or I'm going to stress on this part, or you can take it up to 400 volts with plastic dummy between two contacts. So typically, if you take a 12 ways contact configuration like this, if you want to take up to 400 volts, then you have to ensure that you have got a nice split between 6 contacts and 6 plastic dummies, dummy contacts. I talked about the current rating in the previous slide of 18 amps, and I just want to draw your attention to the contact resistance, how low it is, and the insulation resistance. Now, if I switch from the electrical spec to the bottom left, the silicon and the overmolding grommet, right? This is the point that I wanted to kind of labor in this slide about the IP67 protection. Now, why is this important, right? Because you remember I talked about in one of the previous slides that these connectors are often kind of behind either cabinets or often, I've seen in examples where it has been interconnect solution open left in kind of open weather, if you like. Open weather doesn't mean completely outside, but in areas that's not nicely sealed or behind a panel. Now, in pretty much all environments that I've been to with HVAC systems, one thing is common. The temperature and the humidity often is high in these sort of environments. And it doesn't take long for these humidity to reach a dew point and condensation starting. And in one of my previous slides, I talked about the different failure mechanisms, right? And I talked about humidity. Now, humidity deteriorates the material properties over time. Now, another part of the failure mechanism is that it causes galvanic corrosion of the contact. And particularly when the humidity level is above 50 or 60%, of humidity, the failure mode of corrosion sharply increases. And again, I connect back to the whole story. What happens when you have humidity, when you don't have a nice sealing around the connector? The humidity not only deteriorates the material properties, but that in turn, what does it do? It increases the contact resistance. And when you have increased contact resistance, I'm kind of now sounding like a broken record in some ways, right? When you have an increased contact resistance, you've got higher power losses and it heats up, so on and so forth. The failure mechanisms truly kind of sets off from that point onwards. So hence it is so very important to make sure that you have got a nice sealing around the front and the back of the connector. In terms of mating cycles, it does over 500 mating cycles. It's got a very low retention force, contact retention force of greater than 70 Newton. The clip locking retention is 190 Newton. Polarization available and vibration up to category 2. From an environmental perspective, it can go as low as -55. Now, you might wonder why is it, right? Because as I said, in some instances, we have seen that it can be, the temperature fluctuation can be quite kind of sharp, if you like, and hence we have just to make sure that it has got a very wide temperature range to that end. I talked about the sealing, so not laboring on that point. It's got a salt spray test of up to 96 hours, and it meets and complies with the fire and smoke requirements and the flammability requirements. And finally, on the extreme bottom right, again, I just want to remind the technicians who have to do the job. It integrates plastic clip, retention coating, and can be used pretty much everywhere, whether you're talking about a train or as kind of moving off a piece like a train to any standard data center like HVAC applications. I talked about weight and space savings, and finally, again, I'll end with what we believe is the heart of the design thought process, not only the technical spec, but the application kind of technicians in mind. It comes with this audible log so that the person who is doing that real final job of putting everything together, we have tried to make their lives ever so easy, if you like, to connect the two ends of the interconnect solutions. So again, I'm not going to labor too much on this slide, but I just want to kind of let you reflect when you're looking into a connector against everything else that's available in the market, whether you're talking about a contact technology, whether you're talking about one contact or different cross-section of cables, current rating, IP level. You know, I suppose this slide is a nice way of representing that, frankly speaking, no wonder why Smith Interconnect's products often has become a de facto standard for this application, right? Because if you package all these requirements in one simple body, it's genuinely difficult to find one in the market. So with that, let me switch gears and change and talk about M12. Now, M12 is perhaps one of the most commonly used connector in an application like this, used in a lot of different instrumentation and ancillary equipment that goes in an HVAC system. So in case of Smith Interconnect, it comes with a metal shell with up to 8 contacts. It's available with 2 different types of contact technologies. One is the hyperboloid contact, another is a standard contact with current rating of either 2 amps or 4 amps per contact, available in A and D coding, complete 360-degree EMI shielding. And why is this important? Because I labored in one of the previous slides talking about that often the system being so tightly packed is a perfect environment of high EMI kind of environment, if you like. So we have just made sure that it is completely shielded, 360-degree shielding. IP67 rating, again, why is IP67 important? I'm not going to labor anymore on this slide or in M12, but it's exactly the same reason why we believe IP67 was important in our EP's case. It's compliant with fire and smoke standards, and the overall design is immune to high shock and vibration. Now, again, keeping the designer's point of view, keeping the technician at the heart of the product design, we have taken care of quite a few things. Now, this has been designed for application where space and weight are absolutely paramount, right? It's common housing for inserts with up to 8 contacts, whether you've got 4, 5, or 8 position for insert available. Now, it's optimized for total number of components because we just want to make sure that when you put this against a test of time, we win the race in terms of how easy and quick it is to assemble this product. The versatile cable clamp for cable with shielding braided up to 10 millimeter diameter. Its unique rotating back shell on a 90-degree version is available. Its A-coded version for 5 or 8 contacts and the D-coded version for 4 contacts. It just prevents from mismatching really. Because why is this important? Because again, I go back to this point that when you keep the technician at the heart of this discussion, these little things, right, when they have to do these against the clock, if you like, these little things make their lives ever so much easier and suitable for a variety of different applications. High reliability solution, I talked about without repeating again, the benefits of the hyperboloid contact and why this is important. It's compliant to kind of high data transmission rate, protects against EMI interference I talked about, and fluid resistance against oil, hydrolysis, and microbes. Because again, if you picture the environment that these connectors are operating, these are often things that contribute towards the initiation of the failure mode, if you like. So taking care of the product design so that it's not only technician friendly or assembling friendly, if you like, but also making sure that the environment within which it is operating, just not simple temperature specification, right, or humidity specification, but just really zeroing into understanding the true environment that this product is going to operate under. Oil, dirt, general kind of pollution is very common, right? So we have just made sure that the product design is suitable to operate in an environment like this. Again, I'm not going to labor too much on this slide particularly, but other than kind of pointing out a few aspects of the product. In terms of the straight or 90-degree versions, firstly, the point I'm really trying to bring out is you go back to that one of those slides earlier I talked about that typically in a product that we design, because the electrical contacts are designed in a way that it is able to carry, typically speaking, 30% more current carrying capacity. That ultimately results in a much slimmer design, right? So you put this M12 against many other designs available in the market, you will find that Smith Interconnect's design is one of the smallest and slimmest, if you like, in the market. The outer diameter is maximum, has got a 16 millimeter diameter. The 90-degree free assembled version as angled or straight version is also possible. So there are two couple of points I really wanted to bring out. And again, I'm not going to labor on the rest of the technical specification because they are, as I said, it's designed for applications like this, but I really wanted to bring out those couple of points, keeping the application in mind, why it is important to have a smaller footprint of a product in an application, and the M12 from Smith Interconnect absolutely very nicely lend itself in an application like this. So again, if you put all the different requirements in a boiling pot, right, all the wish list, if you like, small size, 360-degree MI shielding, side-way clip insulated design, a choice of different contact technology that is suitable for an application of this nature with low contact resistance. And again, I'm not going to, for interest of time, labor again and again why contact resistance is perhaps in the heart of many of the failure modes that you typically see. Robust and rugged metallic housing, overmolded and free-assembled version, IP67 rating. Again, I'm not laboring again why IP67 is paramount in an application of this nature. Unique rotating back shell on a 90-degree version so that it becomes easy to kind of install this. And rotatable angled receptacle. If you put all these in a simple boiling pot, right, and try to then compare in a very rational way one product versus another product, you would be surprised, but you would genuinely struggle to kind of find an alternative to against Smith Interconnect's M12 design. And that's the reason, no wonder why many of our customers who have either designed in from day one or have in later phases of their product life switched over to M12, they find M12 to be such a great benefit, to the design, such a great benefit to their overall architecture of the design. So look, I've kind of tried to kind of capture a lot of different aspects of it, and hopefully I've managed to kind of really bring to life two products. Again, I could spend the next many hours talking about many other products we have in our portfolio, but I really wanted to bring to life two products that we have seen time and time again gone into critical HVAC applications, and we have seen how customers have really benefited out of it. So hopefully you have kind of found this discussion useful about how these products, a couple of products I've shown you, are really kind of helping to make sure at least that the connector is not part of the problem statement I said at the very first slide. You remember that 15%? So that Smith Interconnect's products at least doesn't become part of that statistics. With that, I'll hand it over back to Katie for our Q&A session. Thank you.
All right, Jodeep, thank you so much for that great presentation. So as you mentioned, we are going to move into taking some questions from our attendees at this time. For all of our attendees, if you have a question today, go ahead and place it into the Q&A window and click Submit. We will do our best to get through as many questions as we can. And before we start taking questions, I also just wanted to point out a couple things in our webinar console. We have a resource list, which is right below the Q&A window. There are some great items in there for you to take with you today, so please take note of that and start grabbing those before you leave. And there's also a survey which is going to pop on your screen at the end of the webinar. Your feedback is always important to us, so please fill that out if you can. If you'd like to fill the survey out now, there is a survey widget along the bottom of the console in the widget area. You can go ahead and click on that. So those are just a couple items to take note of while we're doing the Q&A today. All right, Jodeep, so we have a couple questions in here that have come in. Our first one, this person is asking, HVAC applications typically in a dry location. Why are you recommending higher ingress protection ratings?
Yeah, no, I think that's a good question, actually. I just go back to this piece about how different aspects come together to create a perfect environment where the initiation of failure mode starts. And over time and time again, we have seen that humidity does play a pivotal or kind of a crucial role in this initiation of the failure mode. If you'll remember, I talked in one of the earlier slides about how humidity basically, and if you perhaps put humidity and temperature together, right, the temperature obviously contributes towards the thermal expansion and contraction, resulting in micro of kind of movements within the contact surfaces, which creates fretting action. But humidity particularly ultimately deteriorates material properties over time. I talked about the galvanic corrosion that it kind of initiates. And particularly when you are in a high humidity environment like 50 or 60%, then that kind of failure mode is ever so accelerated. And what that means, again, other than obviously the material properties deteriorating, it sets in well and truly the increase of contact resistance. And again, I come back to this circular discussion again and again. With this increase of contact resistance, what happens? Your basically power losses starts getting in. You start building up an inefficient system. And worse come to worse, that localized heating can ultimately affect your insulator, and from a failure mode analysis perspective, it can bring your whole system to a stop. So hence it is important that as simple as an ingress rating specification can ultimately, if you really kind of follow the thread of failure mode, can ultimately contribute to a complete system coming to a stop or an inefficient system. So hence, Katie, it's so very important that to have a connector which has got good ingress protection.
All right, thank you so much for that answer. Much appreciated. And it looks like we have one other question in here at this time. So if any attendees have any other questions, feel free to enter those into the Q&A window now and click Submit. So for now, Jodeep, we just have one other question. This person is asking, can you elaborate what you mean by user-friendly connectors?
Yeah, this is also an absolutely great question because, whenever I go out to sites, right, and I reflect also back to the previous question about humidity, right? I've been to places like in Singapore, right, where I've seen a lot of these critical HVAC applications. So, that hot and humid environment just comes to life whenever I think about places like Singapore. But other places, even in places like Singapore, or any other HVAC applications that I've been to, one thing I remain absolutely kind of, struck with awe in some sense that how much of an acrobatic skill a technician needs to have to do their job in an environment like this. They bend backwards, sideways, bend forwards to connect things. And they are doing this every day throughout the year. So what is vitally important for us is in a small but in a very firm way to make their life as easy as we practically possible. So remember in REPs I talked about the audible clipping, right? It's as simple as a click sound, but someone who is doing their job up against time, that one little click, they are assured that the piece of work that they have done to the highest professional standard. In M12, I talked about some of the mismatching kind of design that we have done that you are not able to mismatch it. These little things, right? It just demonstrates that how at the heart of the product design we have taken into account the user friendliness of the connectors, so that the technicians or particularly who is doing this every day can be kept in mind, really. So that is what I mean by user friendliness, right? Again, I repeat this perhaps far too many times, that how much importance we give to the person doing the job as much as we are giving kind of importance to the hard technical specifications that you have to anyway meet. Yeah.
All right, Jodeep, thank you so much for that answer. So those are all the questions we have at the moment. If anybody has a question, you can always enter it into the Q&A window and click submit. This webinar will also be available on demand following today. So if you have a question that you think of later today or even later in the week, you can always come back and enter in your question, and we will get back to you following the webinar. So with that, I am going to start to wrap things up. So I want to say a huge thank you to Jodeep for a great presentation and for answering a couple of the attendees' questions. So thank you so much for being here with us.
Thank you to everyone. Really appreciate for going through this, and hopefully we have managed to kind of articulate how Smiths Interconnect is adding value to this industry application. So yeah, so looking forward to perhaps having many more offline discussions with many of you. Yeah, thank you, Katie.
All right, thank you so much, Jodeep. And then a huge thank you to our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or share it with colleagues. And as I mentioned before, we have some items listed in our resource widget, so please take a moment to grab those before we end things today. And lastly, as I mentioned, there will be a survey that's going to appear on your screen at the end of this webinar. For anybody watching this webinar on demand, you will find the survey located along the bottom of your attendee console, right in the survey widget. So again, I want to say a huge thank you for everyone taking time to attend this webinar event. Take care, and we will speak with all of you soon.